Hopefully it's loud enough. I think everybody can hear me. Yes? No? Okay. So, by the way, if you have any questions, it's just a small group. If you have any questions, just raise your hand, then we can do it immediately. So, not this big Q&A in the end. You can ask questions in the end for sure, but if you have anything, just raise your hand and then we can do it during the talk. Okay? So, okay. Yeah, you will have a good job. You have to follow with the camera the whole time. Okay, let's see. Supply chain security. That is more or less the topic I want to talk today about. We will focus here on developer-centric topics. Supply chain security itself is a very big topic. Anybody of you is already talking about supply chain security in his company? Anybody of you? Yes? The big topic right now. Huh? Yeah, maybe. Huh? It will. Oh, someone else? Feel free. Yeah, supply chain security is something that is coming more and more to us, and it's more and more coming into the developer world. And this is something we should be aware of, and this is what this talk is more or less focusing on. So what I want to talk about is a little bit, I want to explain a little bit what are the stuff about what happened in the near past. So what was a big challenge, what changed a lot of stuff, what started or triggered processes in US, in Europe, somewhere, so we have to deal with this. I want to show, yes? Oh, okay. Maybe a little bit more voice. Okay, better? Ah, okay, then I don't have to shout so loud. Okay, what you heard already? Nothing, huh? Should I start from the beginning? No. So I want to go a little bit to the past, what happened and what are the key features or what are the key changes. I want to talk a little bit about general supply chain itself. What are the key factors that are changing during the last 2 or 3 years and especially during the last 6, 7 months? We saw that a lot of things changing. And yeah, what you as a developer can do about this one. By the way, my name is Sven. I'm from Germany. And I'm developer advocate for JFrog. And yeah, I'm focusing there on this cybersec, DevSecOps, whatever you want to say around the security topics. And by the way, as you can see, mostly every 3 minutes I have, I'm spinning in the woods. Yeah? And if you want to see cybersecurity stuff presented in the woods, go to my YouTube channel, okay? Because then I'm sitting down there somewhere in the green field and talking about additional stuff, okay? So, yeah. Then, I'm not going into all details. So Solarwinds Hack was one of the key things that gave us some advice what we should do. So what happened with the Solarwinds Hack? It's more or less, there was a hacker group that broke into a network from the company called Solarwinds, and they are building a piece of software. It's the Orion platform. And this is more or less an agent-based approach to manage networks. I'm not going into all details, but the basic idea was that they are not stealing or compromising something inside the company. They are not encrypted stuff or whatever. They went to the CI environment from this company, this hacker group, okay? And in this CI environment, they changed the CI configuration. So with every new build, they produced by themselves compromised binaries. By the way, who checked his own Jenkins or CI for vulnerabilities? Nobody. Huh? This is mostly the answer I'm getting. Huh? I'm using the latest Docker image from, and then whatever, Jenkins. Huh? Checked for vulnerabilities? No. Hardened this configuration? No. Okay. So, and this is exactly what happened there. I'm not talking about Jenkins or whatever CI environment they're using. So this was more or less compromised. And this will give us something that is new. So what happened with this compromised binaries, just to think what was the impact of this. The company Solarwinds have 300,000 customers. Okay. A customer is managing networks with the software. So a customer is not managing one server. And they had this automatic update feature for their customers. Great. Then they produced the compromised binaries by themselves and provided via automatic update to every customer. Wow. I think in 2 or 3 days they infected 12,000 customers, 15,000 customers. Having in mind that every customer is managing networks with this stuff. So we are talking about a huge amount of servers that are just infected immediately. The main thing with the Solarwinds Hack was this piece of code was sleeping 1 or 2 weeks and then started downloading additional security payloads. And with this stuff, every infection was completely different. So if you're closing the main door, you have no idea how many open windows you have. So a lot of infrastructure was just destroyed and rebuilt. So this was more or less what happened here. And so we have now 2 things for us as a developer. First of all, I have to make sure that I'm not consuming compromised stuff. That's the first thing. And on the other side, I have to make sure that I'm not distributing this stuff. And this is something that most people are not really aware. So inside their own companies, they're delivering binaries, they're delivering new versions and all this stuff, and then they are distributing it inside their own company. So, and we as a developer, we have to make sure that we are protecting ourselves now against exactly these 2 things, consuming and distributing. So we have the supply chain. The supply chain means that from the idea until something is running in production at the customer side, this is more or less a whole supply chain. It's a big topic. It could be third-party components, material, your own production line, and so on and so on. So even if you're in a very small process, you are part of some kind of supply chain. The main thing with supply chain is that if you're looking at the whole industry, you are some part in some kind of supply chain. And if someone wants to attack something, doesn't mean that you are the main target. You are just one piece in this supply chain for whoever it is. So just looking at my piece and saying, oh, my value is $1 million and I'm not interested for big things. Maybe you're part of a supply chain that is a few hundred million, okay? And then it makes sense to attack you, even if you're just a tiny thing, okay, inside this one. So not only looking on your own thing, looking at the whole supply chain thing, and then you see, oh, who is interested to break into my small company with maybe just 10 developers or so. Okay, so we have some key factors that are changing during the last 2 or 3 years dramatically, and then changing again during the last 6 or 7 months. I think everybody knows what I'm meaning here. But they are using this global events and these global things to use this for attack. So it's not an individual localized thing anymore. So you have to think in global context, because with IT, we are in a global context. The other thing is that long time ago, if you have cyber criminals, you had individuals, very, very well-educated cyber criminals that are doing some dedicated attacks against your company or your thing, okay? But now they are building teams, and these teams are working together. They're sharing hats, they're sharing resources, they're sharing information. So they start structuring themselves to be more efficient. Even just thinking about that, they start sharing resources is a big thing, okay? Another thing that is interesting is that the motives that is behind the cyber attacks is changing. Let's say 5 or 6 years ago, it was mostly driven by money, okay? Having in mind, if you have a 0 day and you are able to find a 0 day, you can get up to $1 million for this 0 day if you're officially selling it on platforms like Zerodium also, okay? So even there, it's a lot of money, but it's mostly driven by money. But during the last years, we found that more and more of these attacks are political motivated. And this is changing the world, because then nobody is asking for money. Nobody is asking for whatever to get something or giving you something back. They just want to destroy because you are unfriendly, okay? Or working for an unfriendly company. So, talking about the whole supply chain, and you're part of the supply chain, means that inside the supply chain, maybe the final target, a big company is. And this big company, during the pandemic, they started investing a huge amount of money for home office places, infrastructure, and all this stuff. And means the hygiene or the protection in this environment is increasing dramatically. And this is pushing the pressure left and right of the supply chain, because they are now going not to the final target. It's cheaper to go over 2 or 3 or 5 steps to the small and medium business size companies that are delivering something to something that is delivering something that is consumed by a big company, okay? And this is something that is changing more and more. So the pressure is going left and right inside the supply chain, and we are now in target, even if you are in small companies. Okay, and the last thing I just want to mention, it's not part of this talk here, is thinking if you're going to cloud, more and more attacks are not only on software, you have the same kind of attacks on hardware itself. You are somewhere in a cloud, you're using some shared resources, someone is able to break into the system and read the whole memory and so on and so on, okay? So we have it on the hardware itself, I'm focusing here on software. So the thing is that here, this picture is stolen from the open source project Salsa. Salsa is a very good open source project, and it's a documentation project. This documentation project will give you advice, what are typical attacks inside the supply chain? What happened in the past? What can you do against it? So there's one thing that you can learn a lot about different attack vectors. And on the other side, it's some levels, they are defining levels. So if you want to see where am I, then I'm checking what level I'm fulfilling right now, and then they give you advice what could be the improvements so that you're reaching the next level. It's just a guideline to work with this topic, to go through this, yeah? And it's a very good open source documentation project from the Linux Foundation. It's still alpha, but the content is good, and it really makes sense to check it every few weeks because it's changing. So I want to go here now to a few parts. I hope you can read it from the last rows, yeah? You can read it. So mostly you have a developer. What are typical attacks? Typical attacks are maybe something like I'm writing code and someone else is writing code and someone tried to sneak in with malicious code. It could be over official merge requests, it could be with everything. So what's the best thing against it is more or less a code review, okay? This is fishing out up to 80% of the attacks. But really it's based on source code, okay? Intentional, unintentional, or malicious packages. I will define a little bit the difference later. But here it's something. So we are working with source code as developer. Okay, because now I'm focusing just on the software supply chain security. I'm cutting out the concept phase and all this stuff left and right. So we as developer, we are writing code. Okay, this can be compromised. Then this code is in some kind of repository, Git or whatever. This Git repository can be compromised, blah, blah, you have to harden it. Sure. So we are talking about source threads because here's modification on source code. Then we start talking about build threads, everything that is part of creating a binary. What is happening more or less? There's a communication between source and build infrastructure. During this time you can compromise it, sneak in with external code pieces and so on and so on. But the main thing is from here to here it's changing to be a binary. And the next infrastructure part is a build environment, how complex it is. Doesn't matter right now. So what do you have to do? You have to make sure that the transition between source, so Git repository, and your build infrastructure is secure. That's one thing. Then you have to make sure that the infrastructure, the build infrastructure is secure. Okay. From this one, I'm pushing the binary to some kind of repository because I want to deliver it. There's one turnaround. It's called here this dependency threads, because during the time I'm building, I'm consuming not only source code, I'm consuming binaries as well. The short message here is, what do I have in my hands as a software developer? Source code, binaries, infrastructure. Who of you is able or who is responsible for managing the infrastructure inside your company? Mostly not. Yeah, mostly it's done. It's hosted or it's done by an internal team. The most developers are working on source code and binaries. Okay, these are the two key points where you can work on. Okay, infrastructure, you have always to make this decision. I'm able to protect it by myself, yes or no. And if I'm not able to do it or I don't have the resources to protect it, I should outsource it. Okay, if it is hosted, not hosted internally, but it's a decision you're not doing on a daily basis. So on the other side, you are working on source code and binaries. If you start reading about the cybersecurity topic, you will come to 4 main topics quite soonish. It's first of all SAST, Static Application Security Testing. It means we have all these bits and pieces and you can scan it, configuration, binary, source code and all this stuff. The good thing is you can scan 100% of the infrastructure if you have access to it. Okay. The bad thing is you're missing a little bit the dynamic context because nothing is running. You can catch some kind of configuration or the dynamic context if you're reading configurations or infrastructure things like the Terraform scripts and all this stuff. But it's more or less scanning for vulnerabilities and malicious codes inside the elements you are using here. The next part is DAST, Dynamic Application Security Testing. It's exactly the opposite. It's you're ramping up an application and then you have this hacker approach. You're looking from outside and then you try to sneak in with most common vulnerabilities. There's most common vulnerabilities. There's a huge list of what it is. It's mostly based on SQL injection, blah, blah, blah. Different other topic is, for example, some kind of fuzzing, how to make this attack. It's more or less a description how to attack the system. But the main idea is I'm ramping up this application and then I start attacking it from outside. The bad thing is I can test just the API and all the other stuff inside, internally, I can check indirectly because I have no access. I don't care about the technology. Maybe I'm tweaking the attack vector because I know about some technologies that I use inside, but that's the main part. I'm checking from outside. You have to make sure that you have some thing like service exposure detection going on and so on. I will cover this a little bit later. But in the main thing, you're looking from outside. If you're combining both approaches, because Dust you can do just if something is already runnable. Thus, you can do immediately with the first line of code. Okay. So if you're combining both approaches, you have IAS, Interactive Application Security Testing. This means you need highly educated, highly skilled and trained people that are able to modify this attack vector. So you're ramping up the application, you have access to all components, you're doing the static tests, you're doing this ongoing attack. During the time, you're analyzing this stuff and tweaking the attack vector. Okay. This thing is very, very good, but it's not scalable because you need a human that is doing it. Okay, it's not done by a machine. Dynamic application security testing is mostly outside done by providers, so you need a good bandwidth. The limitation is more or less resources, how many instances you can run in concurrent mode so that you can scale up or speed up the testing. Zust is just scanning all binaries. Everything can be done on a laptop. Okay, it's a very fast thing. So IS is something you can't start with because you need this knowledge so that you can trust your results. And then there is a fourth thing that you will see and find is runtime application security protection. This is something to protect an ongoing and production system. And the main thing is it's mostly an agent-based approach. So it's something like APM tools. Yeah? You're installing an agent that's modifying a little bit stuff. Then you're collecting runtime metrics out of the application. And this will be analyzed with machine learning, for example, in real time, if there's something strange going on. Okay. And then you have just two choices, alerting or shut down. That's the thing. And runtime application security protection makes only sense in production. So it's really the latest stage. It's the last wall of defense. Okay. So where should I start? With RASP? No, definitely not. It's the last wall of defense, expensive, and you can do it just in the end. And it's just on production. Should I start with IS? Definitely not, because you need very high-skilled people to do this. Should I start with Dust? Well, it depends. It's quite late inside the production line because you need something that's running already. Mostly you have a tool stack that is creating all these attack vectors, and some kind they're modifying this attack vectors a little bit with fuzzing technologies, but in the end, it's based on the most common vulnerabilities. If you really want to start with security stuff, go with Dust. Static application security testing. You can do it on your laptop. You can do it inside your CI environment. You can do it immediately with the first line of code. Okay, and then we have to think about where machines are good, where machines are bad. Machines are good and bad in some areas. For example, cloud native is just an excuse. You can do it with a monolith, you can do it with serverless, I don't care. Cloud native is just an excuse because everybody knows it. It's a buzzword, it's cool right now. Okay. So, if you have a bunch of use cases, is a machine good to decide how to distribute these use cases so that this process is not compromisable? No, the machine is just crap. Okay, that's part of the concept phase. A human has to do it. The machine can't help you. There is no tool to decide, make these two use cases together or not, so that this process is safe. To harden it. Makes no sense. Okay? So the machine is just bad there. If you're going to this microservices start communicating to each other, where's the machine good? The machine is good in securing the channel, okay? Key management, encryption, and all this stuff. The machine is really bad in, can I send two pieces of information over the same wire? Is this good or bad? Or should I use two channels? The machine is just bad. No way. You have to decide it, okay? It's part of the concept phase. If you're going to container-based infrastructure, layer lower, then is a machine good? Yeah, they can start working with resilient patterns, scalabilities, denial of service detection, respawning nodes, okay, version up, version down. There are machines good. Domain-specific features? Not really. But where the machines are really good, really good, and you will get a lot of support is during the time you're working, DevOps, DevSecOps, whatever you're calling it. Okay? It's a time where you're producing this stuff. Coding, managing of binaries, composition of versions and all this stuff. There the machines are good. Okay? Have this in mind. So during the development phase, you have the most impact to secure it. There's one thing. We are adding technology layers more and more. But the main thing is, per definition, if you're adding a next layer, next abstraction layer, you can only add vulnerabilities, 0 or more. But you never are able to remove vulnerabilities with an additional layer. So it means keep it simple is one of the best advice. If you can get rid of a technology layer, kill it. Because there's nothing. The same with compliance. I'm not focusing here on compliance issues, just mentioning the same with compliance. Every additional layer will give you more compliance issues. Okay, so if you're reading, you will see or will get quite early this term shift left. Shift left means that you start talking about security as early as possible. I was able to remember if I'm rotating the picture and say, okay, first writing the application, then going to an operating system and so on. So start with security as early as possible is really something. But to say the truth, we had this discussion with quality. What's the definite best place for implementing quality? Every step, okay? Because it's a cross-domain topic. What's with performance? Makes it sense to have one performance step in your pipeline? No, definitely not. You start thinking with performance even during the concept phase with choosing the right algorithms. A better algorithm is always beating better implementations, okay? Technical tweaking. So the same with security. Security is part of every stage, and you should start as early as possible. If you are thinking about the whole tech stack, there's one thing that is more or less everywhere in software development. We don't want to reinvent the wheel. Means that we have existing binaries, existing implementations in every technology layer. So we are talking maybe inside the application about Maven. Okay, I'm managing dependencies with Maven. Okay, I have Maven. What's there? Versions, dependencies. I'm building out of blocks. The same with an operating system. Yeah, I'm writing a few configurations and then I have a repository where I'm grabbing all these binaries. Then I'm going to the Kubernetes stack and so on. And the most people are forgetting one thing. Their own tech stack, compiler, own scripts, all this infrastructure. Who checked his own compiler that this is not compromised? Just as a side note, search for an article called the Evil Compiler. Great. It's an old article, but it's great. Okay? So, think about tooling as a generic repository. So if you want to make a release, what you need is all versions from this one, but your tool stack as well. I saw so many projects. Yeah, it's running at the customer side on JVM version, blah, blah, blah. Do we have it? Oh, shit, no. Great. Huh? So we mostly have something like time to market or make or buy. So why I'm mentioning this one? If you're talking as a technical guide to the management, do you have challenges with this? Who has challenges with talking with management about things? Well, using different words, talking about the same thing. You're not able to understand. So I have mostly the same challenge. If I'm going to the C-level, I have to choose more words, explaining exactly the same message. Then I'm going to the team leads and managers, I'm switching more words, talking about the same stuff. I'm going to you as a developer, I'm switching my words, but I'm talking exactly the same stuff. Okay. This I'm doing, I don't know, since nearly 20 years now. So it means, yeah, we are talking about the same stuff, but we have to start thinking about it in the same way. Time to market. If I start explaining time to market to a management guy, okay, what does it think about? You're thinking about, I have a use case. It should be pushed to production as fast as possible because I want to charge. I want to make money. Okay, so now you as a developer, you will get the use case. You can start implementing it. And after this, it's allowed to push to production, yes or no? Yes, huh? Yeah. You have the decision to push it to production. Is anybody from the management coming to you and asking and checking it or whatever? No. Huh? You're just pushing it because you have the use case, you have the description, and you go. The whole process is lean, optimized, fast. And then we are talking about vulnerabilities. No, you have to ask this guy, permission from that guy, then you have to ask this one, then you have to manually fill out some formula. I have no idea why. It is a requirement. Kill the vulnerability. Make it this change as fast as possible in production. It's exactly the same use case. It's just a different requirement. See it like a use case. It must be pushed to production as fast as possible. So have the same lean process, the same authority that you can push it immediately without asking several guys and slowing down the process. Make sure that you have this lean process for vulnerabilities or killing vulnerabilities in the same way. Make or buy. Yeah, it's for you mostly. Should I write this PDF library by myself or should I add a dependency? It's the same with consultants. Should we learn it or should we hire an external consultant? He has done it 20 times. He's perfect. He can do it immediately. We are just paying a little bit money. Yeah, it's the same with dependencies. I'm not writing a PDF library out of nothing immediately. I'm doing a lot of mistakes. I have to learn. But on the other side, an external consultant, I have to trust. The same with dependencies. I have to trust because it's coming from outside. So make or buy? Yes. Mostly we are deciding for buy. We are adding a dependency. Handle it in the same way. If you're talking about how many source codes, lines, or what you're doing, should I focus more on what I'm doing by myself or what other people are doing? If you're comparing the amount of lines, what you're writing by yourself, even if you're writing maybe 100,000 lines of code, okay? How many lines of code you're adding via dependency? Way more, okay? If you're going to the operating system, are you writing your own kernel? No. You're adding a few configurations. The rest are binaries. You're adding the whole operating system. Million lines of code just in a kernel, okay? If you're going to a Docker statement, it even starts with a from statement, okay? And then Kubernetes stack and so on and so on. And the whole tool stack again, don't forget it. Are you writing your own compiler? Mostly not. So you're adding dependencies. If you're comparing now how many lines of code you're writing by yourself and how many lines of code you're adding from external, most projects, 99%, don't nail me down on this 99%, but a huge amount of percentage, okay, is added from externally. So where should you start focusing? Sometimes I see, oh, I start scanning my source code. Forget it. Makes no sense. Scan the binaries, because it's the most dominant thing. It's a low-hanging fruit. It's the most impact immediately if you start focusing on the binaries instead of your own source code. If you want to make good source code, code with secure coding practices. By the way, on my YouTube channel, soonish, I have a video about the secure coding practices. This is the thing what you should do, but don't focus on scanning this one. Scan binaries. It's really the biggest impact, okay? Compliance and vulnerabilities. We have, I'm not talking about compliance, as I mentioned before, but if we want to remove, for example, what's the effort to hunt vulnerabilities? First of all, the machine will do the work. Okay, do you have to do something? No, you just have to say, yes, do something. Then the machine is doing it constantly. Have you do it constantly? No, the machine is doing it. The only thing, the machine will give you the result. Now you are able to do something. You have to decide something. But what is a thing you should do? For example, if you're hunting compliance issues or wrong license at the right place, no? Then you have to grab this single piece and you have to replace this with a semantic equal implementation. And this is painful because finding a semantic equal implementation is painful, mostly not done. So you're implementing something or changing it and then you have to write this ugly wrapper around it. Huh? So that the behavior is the same. But the good thing with these compliance issues, and later I will talk about malicious code packages, is that you have to do it just once because the license is mostly not changing. Okay, we are not talking about Jakarta EE, whatever EE and so on EE. Yeah? So this is an excuse here. But if you are talking about vulnerabilities, the main thing with vulnerabilities is I have different vulnerabilities in different tech layers, and inside each tech layer, I can combine these vulnerabilities to attack vectors. Some of these vulnerabilities I can use, some of these vulnerabilities are not usable. So we are talking about remediation, mitigation information, yeah? Contextual analyzer stuff. It means that I need the full impact graph. I have to think about the whole thing, okay? If I'm just scanning my Maven dependencies, makes no sense, okay? Because I need the whole context. One prominent example is Log4j shell. Who was infected by Log4j shell hack? Nearly everybody. Excuse me? Everybody got scared, right. But there was one tiny thing. It was a CVSS amount of 10, the highest what you can get. Who's working with CVSS values? Who knows it? The 3 metrics inside. Who knows what's the base metric? Okay, temporal metric. And how to deal with the environmental metric? Okay. This is the main scoring to say how big is the impact of a vulnerability. Everybody's scared about 10. And then not talking about what is really 10 meaning. So the main thing here is with this log4j hack, yes, we have this vulnerability, but you need the information. Are you using this kind of configuration? Are you using this? Are you invoking this method or not? If you're not invoking this method in your source code, forget it. Don't think about it, okay? So it makes no sense to just look at a single thing. And this is a big, if you're talking about different vendors and different tool stacks, if you have the whole meta information about the whole stack, because you have all this meta information from the dependency management, what is a compile scope, test scope, runtime dependency, statically, dynamically linked, blah, 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 what's a whole dependency tree, and you have done it over the whole tech layer, then you will get the whole impact. And then you can see if vulnerabilities are really critical for you or not. If you want to know more about the lifeline of a vulnerability, check out my YouTube video here. There I had a long thing about what is the evolution and the lifeline of a vulnerability. Where are the points where you can influence the way how to get this information, how to get rid of it? Where are the key points? What are the hidden life cycles of a vulnerability? Okay, it's quite interesting. So, talking about vulnerabilities, nobody's talking about malicious packages, but malicious packages are a big thing right now. It is a growing thing, okay? So, bugs or intentional or unintentional bugs in source code is called vulnerability. And they will get the CVEs. It's an identifier where you can read and identify the entity of vulnerability. We have thousands every year. So, there is a CVE number ABC, and then you can read about it. Just copy paste to Google and you will get a bunch of documentation to identify if this is really critical for you, yes or no. But these are more or less bugs, okay? So intentionally is from people sneaking in with code, try to build backdoors. This is just your own stupidity. I'm just handling files wrong. I'm just taking the input field and pushing it to database, okay? So this is what you can do. So here can you, malicious components are a beast. Malicious components are more or less quite tricky and they will not get in CVE. So finding information and all this stuff will be a little bit trickier. I'm just jumping about a few things to give you an impression where you should thought about or think about and what you can do. Talking a little bit about infection methods to have a little bit technical knowledge. So what is an infection method? For example, typo squatting. Typo squatting is you're just adding a dependency and you have typical typos. And if you have a typical typo, you're writing Jakarta Commons lang constantly wrong, yeah? And someone else thinks, okay, this is a typical typo. I'm grabbing this open source component, I'm adding my payload, then I'm creating the group and artifact ID with this typo and the same version number, I'm pushing this to Maven Central. What will happen? You have a typo in your dependency declaration, then it will ask your repository, it will say, no, I don't know, I'm asking Maven Central. In Maven Central, yeah, I have it exactly in this version. And finally, you got a compromised binary sneaking into an infrastructure. Are you able to find it? Well, if you're able to find typos, okay, beastie thing. But it's quite common. It's used more and more. Masquerading. Masquerading is not only, it's not so in Java, in other technologies mostly. It's more or less you're copying something from the original. So you're copying the whole project, the website and all this stuff, and you try to build some history or some reputation so that people selecting this dependency because, README looks good, it's a long history, a lot of comments and all this stuff. But if you're checking, for example, some metadata in some software packages catalogs, you see, oh, there's a usage just since a few months. Masquerading is just they try to fake a project. It's sometimes stealing original data, yeah? And then you have just a tiny tiny change in the name, but they try to fake the whole project, so that you are actively choosing this dependency. That's one thing. Trojan package is more or less exactly what we know from the history. So it's someone is really creating a library and with a good functionality and then sneaking in with security payload stuff, so some additional functionality. It's mean because the functionality is good, and just a side note, hackers are hacking hackers. So there was a hacker that created a library to steal Discord tokens, and he offered this library, but as additional tiny feature, he added that every stolen token would send to him as well. Okay? And the hackers loved this thing and used it. And he got tokens after tokens after tokens. But now we are talking about really a critical thing. And this is really what I highlight for you to realize. Dependency confusion. Dependency confusion is a mean thing. So you're working inside a company and you have internal dependencies. And if I'm grabbing now your web archive or your Docker image and I'm doing a binary scan, I see, okay, there is this. And even if you're working with SBOMs, I see, okay, there's an artifact and group ID. I can grab out the binaries and then I can work on bytecode modification, okay? I don't need source code for this. What I'm doing is I'm creating with a company internal dependency exactly the same name, also artifact and group ID, with a slightly higher version number, and pushing this binary, what I grabbed out of your project, with modifications, and push this one to Maven Central. This attack worked with every big company, So what's going on? You have a company internal dependency and you say, oh, my colleagues have created a new version, great, automatic version update. Then it's going to the repository, internal dependency, oh, no, it's not here in this version, going to Maven Central, yeah, here it's in a new version, and grabbing this internal dependency of a Maven Central inside your own repositories. Damn. Okay, and this worked quite well. Okay, so we have something like hijacking. Hijacking is more or less they are stealing credentials and doing all this shit to hijack a project. One thing I want to highlight here is the typical hijacking is one thing, but we have now something that's going on, especially during a few months, is protestware. So that people that have political intention hijacking their own project. This example is more or less this library executed on Russian Belarus computers was doing stupid things. So we have to be careful with things like this, okay? So political things are now disturbing our work, okay? And this is not so nice. Okay, then, what are common payloads? What can happen here? For example, they can try to steal credit card information, okay, Discord tokens, blah, blah. But the most people are not thinking about environment variables, sensitive data stealers. It means if you're creating a Docker image in your build agent, and then you're pushing an environment variable, AWS underscore bloop, 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 bloop. What can you do with this? I can misuse your resources if I'm able to get your API keys. So this is a very common attack, and it's more and more used to get access to resources so that I can use this for crypto mining, for attacks, for whatever. But it's then under your name. Okay, so think about environment variables a little bit more carefully. It's the same with Connect Shellback. It's more or less you're ramping up a service that is very tiny, hidden with names like operating system stuff, and it's just sending to an external server. What should I do? Then getting commands, executing it, sending. It's like terminal. Download and execute is more or less downloading stuff. So it's with the Solarwinds Hack, and crypto mining is one thing that is often used because they're burning your money with resources. They just want to misuse this one. So what's the time? 40 minutes? I think we have a little bit. Obfuscating techniques is now an interesting thing. What can you see in your own source code or in open source code? For example, you have this typical, let's say, obfuscator. Obfuscator are just splitting up variable names, renaming the stuff, so that's hard to get the meaning of this variables, okay? It's okay. So the other thing that is used is, for example, encoding stuff in base whatever, so that you're not able to read it, but the compiler is doing it on the fly, and then you see, oh, this is more or less I'm executing a remote call, or I'm grabbing, fetching stuff, sending stuff, whatever. Another thing that is used is control flow flattening. So good advice is if you have if then else branches, make sure that fits on one screen, because if you're splitting it over screens, you can have very weird combination of code blocks. And this in a bigger code, then it's hard to find. And then you have, with reordering and restructuring program modules, sometimes completely different meaning. But now we are coming to two things I really like. One thing is homoglyph characters. If you're using, for example, from the whole UTF space, something that looks nearly the same as ASCII signs, you in the IDE will see exactly what you expect to read, but all comparison, all method invocations are completely different because the machine will see the right sign. The IDE will give you more or less the same. For example, here, the H and the H, completely different. But invoking this method somewhere, you don't see the difference. Okay? This is one thing. But now we are coming to one thing I really like. Who had how to build compilers at the university? Okay. Bidirectional control characters. I love it. If you're reading source code, you're reading from left to right. Okay? Your IDE is reading the source code from left to right. Syntax highlighting is done from left to right, okay? But with these characters, what you can do, in the line you can switch reading from left to right to left until it's reverted again. And then what you can do is, you can activate and deactivating commands or comments in a way that the source code is completely different. This is mean. How to find this? I love it, okay? Because with code reviews, you have no chance to identify this one. Okay, these are just a few examples of what is going on. ResearchJFrog.com is our security research team. You will find additional information. I really love it. So I can't go into too many details, but what is the biggest weapon you have in your hand? In high efficient dependency management. How to get rid of vulnerabilities? You are changing the composition of the same components, but in a different composition of versions, okay? You're changing versions up and down. And the whole mix of everything must be in a way that you are minimizing the amount of vulnerabilities. That is the topic. And the best thing you have in your hand is a very strong test coverage. If you have a very strong test coverage, I'm not talking about line coverage, I'm talking about something like mutation test coverage or so. A strong test coverage. What can you do? You can just change the versions to get the lowest amount of vulnerabilities and let the test coverage run and then push to production. And if your test coverage is really, really strong, that is the best and fastest weapon against vulnerabilities, okay? So, having in mind, that is. So, we had, a few minutes. I think we have a few minutes, huh? Let me check. Yeah, we have a few minutes. Perfect. So, the Solarwinds hack was a disaster. It infected governmental, military, space, defense, everything. All the big things. And in US, really, the big players, okay? And it turned out that the US president thought, okay, now we have to do something. And then it was this executive order of cybersecurity. Who knows what an executive order is? Okay, same for me. I'm not a US citizen. I have no clue what this guy is telling me. What the, and so. So I start reading about it. So an executive order is more or less, think about the US government like a company, and the CEO of this company is a president. The president is not able to change the law, but the president is able to change the way how the company operates. And this is an executive order, and this can be done immediately. And he has done it. And it should be done immediately. So what he told us is in the executive order of cybersecurity, you have to, every software that is operated, used, built, whatever by the US government, and they're using a lot of software, has to fulfill an SBOM, the software bills of materials. So a full list of all components of the whole take stack with fingerprints, versions, and so on and so on. So what do you need? You need all the dependency information from your dependency management things. And most people are stopping here again. I highly recommend to add your tool stack as well, okay, because this can be compromised. So you need all this information from the dependency management systems to create this SBOM. We know it since a long time at JFrog, but during the time we invented it, or started using it, we called it build info. Now it's cool. Now it's everybody talking about SBOM. Build info is a superset of SBOM, and it means that you have not only the information what dependencies are part of, but you have information about the context during the time you're creating this binary. And this is huge impact, because I have a compromised binary or a flaky thing, and how to identify that this is mostly if build agent number 3 is building the binary. How to get this one out of a binary if you just have this binary? No way. So this information about the environment variables, version, date, time, operating system version, and so on, whatever you want to collect, will be collected together with a binary, and this is called build info. Out of build info, you can create an SBOM, because it's just a subset. The build info is a superset of SBOM, yeah? And then you can analyze all this stuff. So, we don't have enough time to talk about the build info itself, but I have a YouTube talk about exactly this build info, what it is, where you can find it in the JFrog platform. If you want to try this, we have a free tier, and then you can do the whole stuff there as well. Okay? Back to the project Salsa. If you are now looking back at this software supply chain security, and having in mind that here packages and dependencies have the biggest impact, now you understand that having the information from this metadata or this dependency management is a huge value. So if you're selecting a tool, make sure that you're not selecting a tool that's just scanning the binary. You need the additional information from the whole metadata, from the package management systems. Otherwise, you're losing a lot of context, okay? And yeah, I really recommend to read at this project, Salsa.io, I think, Salsa.io. So SLSA, and check it regularly, every 2 or 3 weeks, okay? Because we can really learn a lot about it. So now I want to focus a little bit more on, if I'm making here a cut, I will get source code, and then I'm building, packaging, using dependencies. I want to harden exactly this step. And I want to harden this step for open source projects, because I'm getting the source code, and then I want to make sure that the build infrastructure is not compromised, the dependency structure, and so on and so on. Then you should have a view on the open source project Persia. It's initially created by JFrog, donated now to the CD Foundation. It's more or less a decentralized package where you're pushing your source code in your commit. Then it's grabbing the source code, random nodes from this peer-to-peer network will build this and compare the binaries to make sure that all binaries are the same. It's not against source code attacks. It's just about build attacks and later, okay? Build threads and dependency threads. And then it's building these binaries, and if this randomly selected nodes having the same binary, we assume, okay, the build infrastructure was not compromised. And then we are taking this binary and putting it to a distribution layer. And this is more or less where you can ask the Persia network, give me Maven dependencies, Docker dependencies, and all this stuff. Okay, so it's more or less building a robust peer-to-peer network for a decentralized dependency package management system, yeah? So it's highly recommended for open source projects, because we can say how many dependencies are built in the Persia networks, how many from outside, red flag, green flag, and so on. The whole history will be saved in a blockchain. So it's a little bit more complex, as I have time here to explain. Have a look there. If someone is interested in these technologies, we are looking for open source committers. Feel free, and a bunch of companies are working on it, and it's part of the CI environment. So what you can do now, after you learned all this stuff, is it good to do all this stuff just inside your CI environment? No, because you're losing a lot of time. So what is it? So if I start adding a dependency, I want to have this PDF library. Then I'm adding this dependency. If I have this information straight inside my IDE, I will get the whole dependency tree here, and then I can start immediately tweaking the dependency tree or selecting the right version, because I have the whole dependency tree without even coding one line of code, okay? Otherwise, what I'm doing, I'm adding in a dependency, the dependency I'm adding since 5 years, then I'm creating stuff, committing, going to CI, and 10 minutes later it's complaining after I've worked half a day. You're burning money. Okay, ask your CEO if you will get the money as income instead of burning it, okay? So you need this information straight inside your IDE. If you're using X-Ray and Artifactory, we have this free IDE plugin, even with a free tier, you can connect the IDE through this, and you will get immediately this result. If you're on a command line, you can do exactly the same. If you are grabbing dependency, you can scan it. You can scan it on your laptop, okay? If I have created my own Docker image, I'm just scanning this Docker image on my laptop and getting the full power from the X-ray on my laptop. I'm not pushing this infected stuff to the infrastructure. No, that's called on-demand scanning. And the result will be pushed to Artifactory so that you can document it, that you can discuss with your colleagues, that you can share this knowledge, okay? You can scan on command line, you can integrate it, and if this is possible, you can integrate it nearly everywhere. Having a look inside the web UI so that you get additional information about the CVEs. I highly recommend check out my YouTube channel for the CVSS talk to explain what are the metrics, what does it mean, how to identify, how to read in CVSS vector, how to deal with a CVSS calculate and all this stuff. What is an environmental metric? You need it for contextual analysis, okay, to identify what's really bad. And then some other people are talking, oh, I'm not working on IDE, I'm ops guy, I'm working with some kind of Docker tool. Add this information inside the Docker environment as well. The main thing, this is, by the way, the JFrog Docker extension. So, surprise, surprise, I'm working for JFrog. Yes, I'm recommending the free available tools from JFrog. But they're cool. So, what can you do as next? The next thing is, what you can do is, you can check out my webinars, you can go to my workshops, you can try it by yourself with a free tier, and so on and so on. And you can learn more. Project Salsa, highly recommended. Read it. It's an open source. It's a good collection of really security experts. If you like outdoor style security stuff from check out my YouTube channel. I really would like to see as my new subscriber. It's a tiny channel. It's my hobby. So, but on the other side, feel free to ask questions. Okay? Don't write me emails. I hate emails, and emails are just a mess. Okay? Use Twitter, LinkedIn, whatever. No emails. It's a disaster. Really. I want you. So, yeah, and if you have a Java user group or whatever, sometimes I'm traveling, I can come to your meetup, I can come to your company, and so on and so on. Okay? So, then I would say, hey, we have a few minutes left for questions. Any questions? No, killed by information. Okay. I will give you the mic.
Thanks for sharing those details. A quick question. Can you recommend some tools for Kubernetes environment just to auto-scan kind of SBOM, software bill of materials, and you be able just to recognize it's like in single pane of glass?
So the main question is, can I recommend something to scan your Kubernetes environment? Huh? So first of all, Kubernetes is using Docker images. Say, X-ray is scanning Docker images, the whole tech stack. Yes. The next thing is we have Terraform script stuff. And what I can say right now, check out in the near future. There are a bunch of new features are coming. I can't go into detail, sorry. Since we are IPO, I must be very careful. But what I can recommend is check out on my YouTube channel, or on JFrog channel, in the near future. And then you will see cool stuff. Keywords I can give you is something like contextual analysis, something about exposures of application, services, and all this stuff. So what is going on with best practices in Terraform scripts, and so on and so on. Okay? I hope I could give you an answer. Okay, others? Other question? No, everybody's hungry, needs a coffee, a bio break. Okay, so thank you very much for attending. It was a pleasure for me to be here. It's always nice to be here. And yeah, hope to see you soon, somewhere, online, in person, whatever. Otherwise, I'm here tomorrow as well in this unconference. So feel free to ask any question, whatever is necessary. Thank you very much.